Hello, students! Today, we are going to talk about something that you see almost every single day, but maybe you haven't given it much thought. We're going to explore the process of corrosion. Have you ever wondered, why does your brand new bicycle start to look a bit old after some time? Or maybe you've noticed shiny metal gates getting that familiar brown coating. What is actually going on there? Well, that whole process is called corrosion. It's basically the metal reacting with its environment. For example, you might see a black coating on silver articles, right? Or sometimes a green coating on copper vessels. And of course, that brown, flaky substance on iron. That's what we call rust. All of these are just different types of corrosion. So, in today's class, here's what we are going to learn. First, what is corrosion? Then we'll look at the specific case of iron rusting. After that, we'll see how to prevent corrosion and discuss a really superior solution, alloys. And finally, we'll wrap up with the key exam takeaways. Okay, so let's start our scientific investigation by looking at the most common example, the case of iron rusting. So, what are the exact conditions that cause iron to rust? I mean, to really solve a problem, you have to know what's causing it, right? So, is it just the air? Is it water? Or is it both? Let's become detectives and find out. And to investigate these clues, we're going to use this famous experiment, the 3-test tube experiment. Think of each test tube as a little scene where we can test our ideas. All right, so let's look closely at what we observe in each test tube. In test tube A, the iron nails are exposed to both air and water. And what's the result? Yep, we see rust forming. Now look at test tube B. Here, the nails are in boiled water, and there's a layer of oil on top. This means there's only water, but no air can get in. The result? No rust. And finally, in test tube C, we have the nails with something called anhydrous calcium chloride. This chemical absorbs all the water, so there's only dry air. And again, no rust. So, the conclusion is absolutely clear, isn't it? The experiment shows us that for iron to rust, both air, specifically the oxygen in the air, and water are necessary. You need both of them together. One alone is not enough. Okay, so now that we know the culprits are air and water, the next logical question is, how do we stop them? How can we protect our metals? That brings us to our next section, how to prevent corrosion. The idea here is actually quite simple. If you can create a barrier between the metal and the air and water, you can prevent rusting. And that's exactly what all these common methods do. Things like painting, oiling, greasing, galvanizing, chrome plating, anodizing, and even making alloys. They all work by creating some kind of protective shield. Now, one very, very important method you should know for your exams is galvanization. It's a method of protecting steel and iron from rusting by coating them with a thin layer of zinc. You've definitely seen this. Think about those shiny metal buckets, or maybe even some roofing sheets. That's galvanized iron. But wait a minute, what happens if that zinc coating gets scratched? We know that if paint gets scratched on a gate, the iron underneath starts to rust, right? So does the same thing happen here? Well, the answer is no. And this is what makes galvanization so special. You see, zinc is actually more reactive than iron. So if there's a scratch, the zinc basically says, I'll go first. It corrodes and sacrifices itself to protect the iron underneath. It's a pretty amazing idea. Here's another cool process called anodizing. It's a way of forming a really thick oxide layer on aluminum. See, this new thick aluminum oxide coat makes the metal resistant to any more corrosion. It's why you see it used on things that need to be durable, like window frames. So everything we've talked about so far is about putting a protective coating on top of the metal. But what if we could just change the metal itself, make it stronger, better, and naturally resistant to rust? Well, that's where we find the superior solution, alloys. Just look at this comparison. On one hand, you have pure iron. It's pretty soft, it stretches easily, and of course, it rusts very easily. But now look at stainless steel, which is an alloy. It's hard, it's strong, and most importantly, it does not rust. What a difference, right? So what exactly is an alloy? Well, it's a homogeneous mixture of two or more metals, or even a metal and a nonmetal. It's prepared very carefully to get just the right properties that we want. This table has some really important alloys you should know for your exam. First, stainless steel, which we talked about. It's made from iron, nickel, and chromium. Then you have brass, a mix of copper and zinc, often used for decorative things. Bronze, a mix of copper and tin, You see it in metals and statues. Solder, which is lead and tin, has a low melting point, which is great for welding wires. And even 22-karat gold is an alloy. Pure gold is too soft for jewelry, so we mix it with copper or silver to make it harder. All right, everyone, that was a lot of information. So let's just quickly go over the key exam takeaways, the things you absolutely need to remember. Okay, here are the quick revision points. First, corrosion is the slow destruction of metals by their environment. Second, and this is very important, for iron to rust, both air, or oxygen, and water must be present. Third, we can prevent rust by painting, oiling, or galvanizing. Fourth, remember that galvanization uses zinc for that special sacrificial protection. And finally, alloys are mixtures that improve a metal's properties, like making it harder or rust-proof. So, as future engineers and scientists, I want you to think about this. How can understanding alloys help you build a better and more durable world? Because this isn't just about chemistry class. It's about building stronger bridges, better cars, and all the amazing things of the future. Something to think about, isn't it?